Hello, and welcome to the Scientific Adventures of Beardman. Today we're going to be taking a look at a concept builder on physicsclassroom.com titled Color Pigments, under the topic of light and color. I've linked a few of the more foundational videos up here, so take a look at those if you need some review or you didn't cover them in your class. Today we're going to focus on pigments. So first of all, before we get into what are primary pigments, let's review what primary colors of light are. We can see they are colors of light that trigger just one cone in your eye. Again, check out those foundational videos if you don't know what a cone in your eye is. And those are red, green, and blue. You have a red cone, a green cone, and a blue cone that are triggered by, no surprise, red light, green light, and blue light. Now, primary pigments. Pigments are like paints or dyes in clothing, okay, or in paper or whatever, that absorb just one of the primary colors of light. Okay, and those are cyan, yellow, and magenta. And the reason absorbing one primary color is key is because most of our lives we spend in white light, meaning light with all of the colors of the spectrum, all the wavelengths. Okay, so if we can absorb one of those colors, then we're on our way to controlling what we see. First of all, I just want to point out that if you ever buy toner cartridges or ink cartridges for your color printer, you'll get black pigment, but then you'll also get cyan, magenta, and yellow, because each of them remove or absorb one of the primary colors of light. All right, let's look at how that works with your eye. So if you have a pigment that absorbs blue, so a primary pigment absorbs one color, keeps one cone from triggering, then that means that you received green and red, which we see as yellow. So if we absorb blue, we get yellow. If we use yellow pigment, what we're doing is we're absorbing blue. If we have cyan pigment, which means the green and blue cones are triggered, that means that that pigment was absorbing the red. And so if we have cyan pigment, that means what it is doing is it's absorbing the red light, keeping our red cone from being triggered. And finally, if we get blue and red, we see magenta. That means if we have magenta pigment, it means it's absorbing the green out of the white light, and therefore the green cone is not being triggered. That's what magenta pigment does. Here's a little table to help you with this. The pigment is listed on the side here. So if you have a yellow paint, yellow dye, a yellow shirt, what it is doing is it's allowing the red and green light in the white light to be reflected to the eyes of the person who is seeing this shirt, piece of paper, whatever it is. And that's happening because out of the white light, the color that is being absorbed is blue. Similarly, cyan is when blue and green are reflected. That means they get to our eyes, and therefore we see cyan. But what did it do to the white light? It took the red out. So the red was absorbed from the white light. And finally, magenta absorbs the green, which means the red and the blue are left to be reflected to our eyes. We're going to primarily focus on the pigment and the absorbed color here. As we think about pigments, the key thing is, what are they absorbing? You could say, what are they subtracting from the white light or from whatever light is present? Because whatever they absorb is no longer going to be there to be seen. That energy has turned into thermal energy, and so these photons do not exist anymore after they get absorbed by the pigment. Let's take a look at the Apprentice level. It has the name that pigment. We can see different colors of light are headed towards the same sheet of paper of unknown color. That's what one of the things we're trying to figure out. The results are shown. What primary pigment or pigments are in the sheet of paper. Okay, so if we take a look at this light right here, we can see that the cyan light is made up of blue photons and green photons. So when those get here, since we're seeing green, that lets us know that the green was reflected and the blue was absorbed. What absorbs blue? We can see blue is right here. So that means yellow pigment must have been used in order to absorb the blue. Okay? So you would click on yellow pigment because that absorbed the blue. Next, we can see that the yellow light hitting this same piece of paper. Yellow is made up of red and green photons. We can see that the green again is reflected because that comes to our eye. We see green here on the paper. And we don't see red, otherwise if we saw green and red, this paper would look yellow. Since we don't see that, that means the red is being absorbed. Well, what absorbs red light? That means we also have some cyan. That means if we wanted to print out on a white sheet of paper this color, we'd need to have the printer would need to use little tiny dots of cyan mixed with little tiny dots of yellow, and that would absorb both the blue and the red, and the paper would end up looking green. All right, let's move on to the master level. So here in the master level, there's two basic kinds of questions. I'll go through both of them. The first is, here we see white light. White light contains all the colors of the photons. So that's red, blue, and green. Okay, all the colors of photons are headed towards this shirt because it says a white flashlight is shining on a shirt that contains, oh, here we go, here's some more information. Be sure you're looking up here, magenta and cyan pigments. What color will the shirt appear? Well, what does magenta do? Magenta absorbs green. So the green is going to get absorbed by the magenta dye, probably, magenta pigment in this shirt. Then we see we have cyan pigment, and cyan pigment absorbs red light. So now we know that the red light is going to get absorbed. Okay, and that's all the pigment we have. So that tells us that the blue is going to get reflected, and that's what we will see. Okay, I'll try and draw a face here, but I think I'd butcher it. So that's what would enter our eyes is the blue light, because the green and the red got absorbed. So this shirt would be blue. The other kind of question you'll see on the master is obviously similar. We're shining lights at a shirt, but this time we're not shining white light. So we have to pay attention to what colors are in cyan. Well, cyan is made up of blue light and green light. There's no red light in this. So that means no red light could bounce off the shirt since we don't have any red light incident upon the shirt. But we see that our cyan flashlight is shining on a shirt that has magenta pigment. Well, magenta absorbs green light. So the green light is going to be absorbed. But since there's no yellow pigment to absorb the blue, that means the blue, after it hits the shirt, is going to get reflected to our eye. So we won't see any green because it's getting absorbed. We won't see any red because it's not being shown on the shirt. So the only thing we see is blue. And again, we end up with a blue shirt. All right, moving on to the wizard level. Gumdrops. You just sent a gumdrop picture to the color printer. What color ink must the printer use to color each part of the picture as intended? Sorry, the printer is out of black ink. Okay, so keep in mind, we almost always print color pictures on white paper. So if we don't put anything there, it means it's going to reflect all of the colors. So if we were printing like this part of the page, we wouldn't print anything. We would not absorb any of the colors, and all three colors would come to our eyes and we'd see white. So if we take a look at yellow here, if we want to get yellow out of white light, that means all three colors would be coming onto this gumdrop because we're in white light and we're using white paper. So all three colors are headed towards it. If we want yellow, that means we want the green and the red to reflect because that's what we want to get to our eye in order to get yellow. That means we're going to have to absorb the blue. Well, what absorbs blue is yellow pigment. So for number 1 here, which is our yellow gumdrop, we would want to use yellow pigment, which kind of makes sense. If we only use yellow, then we're going to see yellow. So if we want this to appear green, and we have all the colors coming towards the green, and if we put nothing here, we know white light would reflect, but all we want is green reflecting. That means that we want the red to be absorbed and we want the blue to be absorbed. In order to absorb blue, we need to use yellow pigment. So this is number 5. So we want to use yellow pigment to absorb the blue. And since we want to absorb the red, we need to absorb the red. That means we need to use cyan pigment to absorb the red. So we mark cyan down here. And so if we use cyan to remove the red and yellow to remove the blue, that means the only thing left will be the green, and we get this green gumdrop. That should take you through all of it. Just remember, black is what we see when we're in a room that has absolutely no lights on. Everything's dark or black. So when you're trying to get black, make sure you remove all of the colors of light. All the colors of light need to be absorbed in order for us to see black. All right, have fun puzzling that out. Keep exploring, keep inquisitive, and keep those beards bushy. We'll catch you the next time on the scientific adventures of Beardman.